In the last video, we talked about the basics of scrolling, and then the next thing people usually ask me about is like, how do I make gravity in platforms and those traditional kind of video game style? And often it's a combination, right? Like you're doing scrolling plus platforms and gravity. So I've tried to incorporate as much of that as I can for you. So again, you can just kind of use my classes and write your own code. So the classes that I'm using here, the real actor, just briefly, that lets you use decimal coordinates, decimal movement, decimal rotations, those kind of things that it's easier to track. So quite a few of you will probably make use of that, even if it's not platforms or if it's not something gravity driven, because that way you're more robust in keeping track of the movement of your characters. You don't get the pixel to pixel movement. Now, the RealMover class, this is one I tried to incorporate, tried to give you like the simplest sense of how you could use it, but the RealMover is one who uses the forces, like you can apply gravity and other things, the way the forces work in physics. So he falls, oh, there, and he landed on a platform. So any platform, that's why all of my platforms inherit from here. There is no code inside them, right? I mean, if I show you what the wood block is, it's just a picture. But because it's a platform, Java knows that I'm touching a platform. That's one way it registers the ground. Again, the ground is another type of platform. If I fall that way, I'm on the ground now. So I can now move left and right, as you can see, because I'm touching the ground. I can also jump because I'm touching the ground. So I'll show you what my simplest possible implementation was in this gravity Mario. What I did was I extended the RealMover. Okay, so those are the classes that you'd have to import to your project: Real Actor, RealMover, and Mario. This gravity Mario is both a RealMover and a Real Actor. So I have the speed like I did before, and this time I made an extra constant for how hard his jump strength is. That's the process keys. That's it. This other stuff underneath me, that's all suggestions you can have a look at later. Just try some more sophisticated kind of movement, just to see how you could take more control over how the RealMover works. But in the default, which is what most people want anyways, move left will do the left movements. It basically does as I said. You can only do it when you're touching the ground, and you can't move through a platform. So let me just see if I can show you what I mean here. If I put Mario on this platform, let's just see if he'll... No. I'm trying to show you that if I try to bump into something, he's going to actually be stopped by the platform, but it doesn't look like I left anything on the ground to bump into. But if this were like an actual physical block here, like where the mouse is, that he'd be stuck. So move left also enforces that. You can't move through a platform either. Move right's really similar, just different direction. And jump makes the jump go. So there it is, keyboard plugged in. But now that I've done all that, all this does is sets up the physics. Then your job is to say, all right, RealMover, do your movement. So that's the same thing that I have down here. You apply some forces, you do, check how things are going, and at the end of it all, you're going to need to call move. And again, that is to say, hey, RealMover, I just put forces on you, apply those forces. So if you're a physics kind of person, a jump is just when you apply a force to the ground. Jumping means you apply a force up on the ground, and that pushes you up when you jump. Same thing when you walk left and right. So that's the most simplest protocol that you can do to have a platform/gravity actor here. I'll just show you one more time real quick, was to extend my RealMover. You'll need to import both those classes to your project. And then when you want to process your keys or hook up a keyboard, this is the most basic one. Move left, move right, and jump. Those three methods will do most of what you want on a platform. Once you've done that, remember that only puts a force on Mario. Then you have to call super.move. And the reason that has to happen at the end is there could be many different kinds of forces acting on Mario. So when we call move, it's the culmination of all those forces at once, right? Like falling to the left, falling to the right, whatever's happening. It's trying to model the physical world a bit better. Now, one other thing that I'll mention briefly here about the gravity, of course, is that scroll bars is what I'm looking for. So here, the gravity of one, the design decision that I made about I want each character to have its own gravity was so that way you could have characters that fly, you could have characters that just float, you could have maybe a power-up where a time where Mario can actually have zero gravity, And then you'll need to change the behavior, right, to say he doesn't need to be on the ground when gravity is 0. But anyway, you have that kind of flexibility because each character gets its own version of a gravity. You can make some characters fall faster than others. You can make some have less gravity. Maybe they jump higher, jump faster. Again, all things which you then can implement because gravity is not applied to everyone equally. So yeah, there you go. That now, once you set up your platforms and you have your support classes, you should be able to then start playing around with gravity in those. Please ask me if you're looking for any kind of special customizations or anything that's not already clear from the video.